Okay, I believe we're live now. Right. So, ladies and gentlemen, welcome to the show. ICSS presents Network Security for Enterprise. I'm Sid J from ICSS, Cybersecurity Analyst, and we'll be discussing a couple of topics which may be of real use. Every day we're using the internet, we're using the web. So let's discuss a little about network, what it is, how we can stay safe and secure. Presentation is brought to you by ICSS, and do get in touch with us in case you like everything. And I'll first introduce Sir Devashish Soroy. He is a network specialist, and he'll be walking us through the network part of how we can actually stay secure, what the network is, the structure. So, ladies and gentlemen, I'm going to be putting this over to Devashish, sir. Sir, please take over.
Thank you, Sujati. Hello and welcome to this webinar on network security and its risk and enterprise solutions. My name is Devashish Rai. I'm the senior network trainer as well as the Cisco networking specialist at the Indian Cyber Security Solutions. And you can see my contact informations for LinkedIn, Twitter, and Facebook in case you want to contact me. Okay. So now let's begin. So first, we need to understand what is network security. See, the network security, it is a set of rules to protect the integrity, confidentiality, and accessibility of computer networks. Integrity means that if you are sending a packet from one location to the other location, the packet should be delivered in its entire format. No packet should be lost. So that is integrity. Confidentiality means nobody will be able to hack your data, means you have to encrypt the data packet and to accessible the computer networks, that easy accessibility, that should be secure. Now, to do that, you can implement some firewall rules for that. Now, what is a firewall? It is a method to actually protect your network from outside unauthorized access so that nobody can hack your, say, web server or file server, DNS servers, these servers. And for that, you can block the port number of the specific services. Means you can block the HTTP port or FTP port or your DNS port number so that nobody can actually hack into your network. Now, that is one measure to actually secure your network. Another one is very simple. That is, you can set permissions. If you are the administrator, then you can set the permission for any object level access, say any file or folder access. You can set, say, NTFS permissions, or previously when we were using, say, XP or 2003, 2008 environment, then there was FAT permission, the share permission for shared drives. So many permissions can be there. And nowadays only we use the NDFS permissions. So these are the basic methods to secure your network from outside attack. Now I will discuss some specific aspects of Cisco networking security now to secure your Cisco router access. And that is setting passwords for Cisco router. Now, different passwords can be set on a Cisco router to prevent the unauthorized access. What are those? The number one is enable password. We know that in Cisco router we have the privilege mode to view the commands, but anybody can access the privilege mode. Now you have to prevent that. For that, you have to set up an enable password to control the privilege mode access, and it is not very secure because it is a clear text password. Now, the other is enable secret password, that is also used to control the privilege mode access, and it is encrypted by the MD5 algorithm, and it is more secure. It is a very secure format. And another one is console password to control the router terminal access. You need to set up a console password so that nobody can actually access your router terminal. It is the most secure format of password. So these are the passwords you can set to actually control the router access. Now this was the password, and next we'll concentrate on our main topic for today for Cisco networking security, that is VPN or virtual private network. Now VPN is a WAN protocol, means it is a WAN service that is used to send the data from one location to the other location, from one city to other city across WAN links. Now it is a very secure protocol to transport data across WAN link. Now there are many protocols, like previously we had ISDN. Then before that there was simple dial-up networking that was very insecure. Then we have simple internet, that is a public network that is very insecure. And also we had ISDN, integrated service digital network, that was also a bit slow. It was speed of only 144 kbps was there, so it was very slow network. After that we gradually moved to lease line, and then subsequently to multi-protocol level switching. But VPN is the most secure format of network, and we can use VPN over MPLS layer 3 network also. Now VPN, why is it so secure? Because it uses a tunnel. Yes, that is a VPN tunnel. It is a logical path. What is a tunnel? It is a logical way to send your data in the encrypted format. So nobody can actually hack into your VPN tunnel easily. And public IP is assigned by internet service provider to VPN routers. If you are using routers, VPN routers in both the locations, then you should purchase public IP from the ISP, because it's a public network after all. So why is it virtual? Because it is not your private network, because you are getting VPN connection from public ISP. So how it can be a private network? It is not. It is a virtual private network, but it is done by ISP. The public IP is assigned by ISP. So that is why it is a public network, but it is very secure, and it is as secure as your private network. So that is why it is known as virtual private network. Now there is a figure of the VPN, and VPN GRE figure means generic routing encapsulation. This protocol is done to encapsulate the data in VPN. You can see that there is a VPN GRE encrypted tunnel over the internet between R1 and R2, and you have a tunnel 0 interface, and IP is there as 172.16.0.1 and 0.2 respectively. And also you are using a public IP, in this case in fast Ethernet port, or it can be the serial port also. The public IP is 11110 and 22210 respectively, and to connect to different networks of 192.168.1.0 LAN and 192.168.2.0 LAN. Now here the GRE, it is an encryption protocol. It is actually encapsulating the data, and the data is traveled through the serial, or in this case the fast Ethernet interface, and through the routed protocol, means the IP. IP is the main routed protocol here, but GRE is only to encapsulate the data. GRE is not carrying your data packet. It is an encapsulation protocol, but the main passenger protocol, that is the routed protocol that I call, that is IP. So your physical interface would be your that physical fast Ethernet interface or the serial interface you are using to actually carry the data. So your source and destination would be the physical port, not the tunnel interface. Now there are some features of a generic routing encapsulation protocol. It is a protocol used by Cisco and made by Cisco to encapsulate data over VPN tunnel, because previously we use IPsec protocol, Internet Protocol Security. But nowadays we use GRE, because GRE is very easy. It is very simple protocol. Now, GRE provides a single mode tunnel to carry different encapsulation protocols. It can encapsulate with IP, even IPX, though we do not use IPX much nowadays because it is from a novel network protocol, but it can encapsulate different protocols using a single mode tunnel. GRE only encapsulates the payload or the packet. So it is, we can say it is not much secure. It is not as secure as the IPsec, because it is encapsulating only the payload, the packet. But GRE supports multicast routing. Yes, this is a feature that is supported by GRE, but we do not see this feature in IPsec. And now, what are the IPsec features? Internet Protocol Security, that is IPsec. It provides the privacy, the integrity, and authenticity to information that is carried over the VPN link. And for a very long time, Cisco used this IPsec VPN as the only protocol to encrypt the data packet inside the VPN line. And still today we use it, but VPN is a bit complex and its commands are very long. IPsec provides two modes, that is tunnel mode and transport mode. Now, what are those modes? Tunnel mode is used in gateway to gateway communication, means router to router, means in VPN. But transport mode is used only in case of LAN environment. Say, generally it is not used, but you can use a transport mode to actually encapsulate the data in a LAN environment between two pieces. And technically, there is a difference between two modes. In tunnel mode, the entire packet, means the packet, the payload with its header part, trailer part, everything is encrypted. So it is a total encryption. But in case of transport mode, only the packet, the payload is encrypted. And as I've shown you, as I've told you, that IPsec is more complex and it is more secure than GRE because it is encrypting the entire packet. So it is more secure. And it uses IKE, Internet Key Exchange, for negotiation. Means IKE, you can say it is like a password that is set between two parties, say between two PCs or two routers. And if they match, then the security association or SA is formed. It is SA is like an agreement between two parties, and only then the communication happens. Now, these things are not there in case of GRE. We cannot actually give any password or key like that. So we can say, yes, IPsec is more secure. GRE is only giving you encapsulation, encryption, but IPsec is giving you more security and authentication also. So this was the theory part between the GRE and IPsec comparison, and I've told you the VPN theory part, and now we'll concentrate in its practical implementation. Means I will show you how to configure the VPN GRE using Cisco Packet Tracer. So here, that is a Cisco Packet Tracer interface, and you take a router. Say this is a PT router. Now you go to CLI. Say the router is booting. Now first we'll set up the passwords, the enable secret and console password, and then we'll configure the VPN GRE. You go to config mode and you give enable space password. Say anything, say 123, then enable space secret, say 456, and to set up the console password, you go to line console 0 because there is a single session here. Give password, say anything, say CCNA, and you activate it by login, Control Z, and you save that with copy run start. And just reload the router to verify the password. Press enter. See, it is asking for the console password. Here you have to give the CCNA. It is encrypted. You cannot see this. And now to enter the privilege mode, give enable, and it is asking for the enable secret password. If you give enable password as 123, it will not take. It will take the 456 because it is more secure. Yes, we have entered the router privilege mode using the enable secret password. So this was the password. And now to see the VPN GRE, you have to take another router. So this is a PT router, and you have to take another router also. But in case of PT router, we cannot actually show you the tunnel interface. So actually I'm going to cancel this router, and you take 1841 series router this time to do VPN. And here you assign the serial interface, you switch off the router, and you assign the serial interface. Otherwise we cannot give IP to the serial interface. Serial DC and DT. Now we go to the router. Interface S0 by 1 by 0. Just configure it. Say give any IP address, say 11001. And similarly on this router also, eleven zero zero two. Now you configure the tunnel interface tunnel space 0. So the tunnel interface is a logical interface, it is already up. You give the IP address, say 10001. Tunnel mode GRE space IP. IP is a routed protocol. Over that you are configuring GRE. Then the tunnel source would be serial interface S0 by 1 by 0 serial port, and the tunnel destination would be the serial port's IP address of the other router, that is 11002. And see, the tunnel interface has come up. And in router 2 also, interface tunnel 0, you give the IP address 10002. Tunnel mode GRE space IP. Tunnel source is a serial interface, and tunnel destination will be the 11001, the physical serial port's IP address, and the tunnel is up. And here you can see the tunnel by show IP interface brief. You can see the tunnel interface that is up here, tunnel 0. Also you can verify it by show interface tunnel 0, and you can see the tunnel 0 is up and the line protocol up is connected. And you can also ping the IP address of the tunnel, that is 10001. Yes, it is pinging. So your tunnel is working and it's encapsulating the data. You can see the tunnel protocol is GRE and the transfer protocol is IP. So that is about the configuration of VPN GRE tunnel. So I've shown you the configuration of the VPN GRE, and also I've shown you the configuration of the passwords. So like this way, we can actually secure the Cisco networks, the Cisco routers. I hope you have enjoyed this, and I hope it was informative for you. So you should join the Cisco CCNA course at the Indian Cybersecurity Solutions to know more about the network security, how to secure the network, how to secure router access, how to secure switch access, what is switch port security, which is DHCP snooping, what is ACL, access control list. So all those things you have to know by only enrolling in the CCNA course at the ICSS. So I strongly recommend to you to join the CCNA course as soon as possible to give your career an extra edge. So that is for the network security part as per the Cisco networking is concerned. So I hope you have enjoyed this session and thank you for joining this webinar. I'll come with some other topics some other day. So thanks for it. Over to you, Siddharthi.
All right, so that was a handful and pretty good from Devashish sir. So, ladies and gentlemen, sir has mostly covered up almost all the points related to networking. So, as far as I believe, we'll be discussing a few practical aspects, everyday affairs we face. Like we are using the internet, so why don't we discuss a few things that would actually help everyone on the run? As far as already discussed about routers, we can already see that routers are, I mean, pretty secure if you can take a look at it that way. But the internet is mostly a very secure infrastructure. I mean, it's a secure structure. So if the internet is so secure, then why do we have to stay so aware? What is the main defense in network security or any kind of cyber platform security? So, if we take a look at that and dig deeper, then let's check the agenda for the day. We'll be discussing a little about SSH, a demo on a router, and about HTTPS, like websites, how we can be a little secure. So instead of continuing, I believe that I should give you a deeper idea by moving directly into the matter. So first, let me pick off where Devashish sir has left off. Let's talk about routers, right? So what kind of security do routers actually have? Everybody knows about the surface level protocols like HTTP, the TCP, the DNS, the ICMP packets, right? So, like everybody knows that when we are typing a website, we have HTTP over the network, right? So let's take a look at that. Let's take a website. Okay, I hope that my screen is now visible. Right. So whenever we are typing a website, so what do we actually type in a website? What do we see? On the left hand corner, we type a website. We see things like that's how we go, right? www, is it yahoo.com or is it facebook.com, right? Facebook.com. So is there something beside the www? Right, of course there is. There is this. Now, everyone knows that over the years, we've been using the HTTP protocol, right? Hypertext Transfer Protocol. So, what was so wrong with it? What was the necessity? What could be the issue with HTTP that caused us to create? If I use HTTP Facebook.com, will Facebook open as an HTTP site? Well, let's see. No, I don't think it will. Because Facebook is configured to take only HTTPS. So what do we have here? See, can you see? I have not added an HTTPS to this. Let me show that again. But every time I press enter, every time I remove the S, Facebook will always put the S back in its place. And what about this? We have something interesting we can see for a moment before the connection is established. We can see there is an exclamation mark on the top corner. Let me point that out for you. See, so that is the time taken by the client and the server to establish a connection over the secure socket layer. That's the layer of security we are talking about these days when we are using the internet for any purpose, be it a Facebook login or an Instagram login, or maybe even just observing a website like a blog site. Let's take a look at this, like Quora.com, right? So this also involves some login, but in order to view the page, we don't have to log in anywhere. Okay, sometimes if we search something, maybe we don't have to log in. So how about that? So we don't have to log into Quora.com to see these articles, right? But still, Quora.com has done what? Has secured the line. What if we change that? We can't. It will automatically put in the HTTPS. So what could be the issue? See, in HTTPS, the issue is that HTTP protocol, nothing is encrypted. Everything passes through clear text, so it can be intercepted. I can see passwords, I can see login IDs. So there was a necessity. There was a necessity to acquire a secure medium so that no one can see my password when I'm filling in this particular form. So we needed the secure socket layer, we needed the transport layer security, and thus was the advent of security in the modern internet system, which is HTTPS. Apart from that, we have today's agenda of SSH. You see, modern day, we don't use the FTP or telnet services like we used to. There was a long time ago when FTP services were used to transfer binary files. But these days we have a more comprehensive framework. It's called the SSH, the Secure Shell Protocol. So, what is the purpose of this protocol? If I can just get access to my command shell remotely, then why do I need a secure shell? Well, simply because the command shell is not enough. We need something to prevent unauthorized access to our system. So, how do we do that? Why do we need that? And is SSH completely secure? Can SSH, can there be an advancement in the security? How do we protect ourselves? Well, let's dig deeper into that. First things first, what could be the possible vulnerabilities in the TCP structure, the domain name system, or the ICMP packet? Let's talk about ICMP. If I conduct a scan, supposing, as Devashish sir said, this is a very, well, not so updated operating system of a router. Okay, so we are logged into a router, and we can basically see IP addressing protocols or configuration protocols on this router, right? So fine, it's running, it's connecting to the internet, but is the router secure? Can the router password be retrieved? Well, let us see. First of all, in case of network security, I really want to talk about ICMP packets, like what kind of ping sweeps we can do. If we ping the router on its IP address, what do we get? Well, we get a reply, of course. And what else do we get? We know that the router is responding to our calls. So I would like to know anything and everything which is around my network. It's not just one router I'm connected to. I'm speaking with you. It means I am connected to my own router. I'm connected to a virtual router. I may be connected to other networks. So what about ICMP protocol all over the network? Is it completely secure? I don't care about any IP addresses. I want to know how many IP addresses I can actually find as targets. Well, there you go. I have my own router. I have my virtual router. I have my own system. I have my virtual system. Everything with an ICMP ping sweep. Now, that is one of the major issues with ping services. What about the domain name system? There is something called DNSSEC. Sir was talking about it earlier. So, if we talk about DNSSEC for a while, then why do we need to secure the DNS service? Domain name system actually maps the IP addresses to the domain names. If I can configure the domain name system to mismatch the IP, I can redirect any person to come to my IP address instead of google.com or facebook.com. And thus came the advent of domain name system security or DNSSEC. And similarly, for remote login, we can use FTP, right? FTP on what? Any server. So why do we need SSH? Because FTP is not enough. We need SSL over the HTTP. We need a secure shell for remote login. But my question to you is, how secure is a secure shell? How secure is the SSH service? Well, for that purpose, let me demonstrate. If I want access to the server, obviously I can log in access to the router. Obviously, correction, the router. If I can log into the router as a user, okay. Well, I can log in because I know the password, because I am a user. But what if I don't want to be a user? What if I want to control this router? What if I wish to have administrative privileges? Then Sir has configured a Cisco router. Cisco routers are extremely secure. So, is there a possibility that I can acquire something from this particular router? Can I have admin privileges? Maybe I can. Let's see. So I do not know the password for admin privilege, right? But what if I try? I want to be admin and I have a list of guesses which I can use, right? So I'll try to guess the password for admin. Let's see. So I await the results, and there we have it. The password for admin is ABCD. So why don't we try logging in, right? Okay, it's ABCD. Right, so now I'm admin and I have complete access to the router's privileges. You see, I can see what is here. I can see on my system here. Simple as that. Now, how do I actually get the passwords? How do I guess these passwords? Well, let's take a closer look by using some other item at our disposal. So on this, we can see a line for line print of how many passwords are being guessed and which password is actually going to work. So as this keeps working and tries to get its results and tries to get the password for the router, let's talk about HTTPS further. How do I see whether a website is proper, whether its certificate is actually worthy, or whether we can connect? You can see some site information on the left hand top corner, a padlock. If we click on that, we can see connection is secure. We can also see how many cookies are in use. So can we see whether the cookies are encrypted? If we log in, we may be able to see. Well, we can see the cookies are not showing us any values, only a session ID. Right. What can we see about the website? A valid certificate showing us details of signature algorithm, the encryption, because all data flowing through the network via HTTPS is encrypted. It's usually MD5 or SHA-256. We can even see the certifying authority. It was DigiCert. And there we have it. I believe it's done by now. Yes, it's done. So we can see that admin password is ABCD again. So the question comes that even for SSH, everything is not as secure as it looks. There is the one thing which we need to actually secure our network is awareness. So, ladies and gentlemen, your greatest strength is your awareness, it is your knowledge. So, that's about it from my side. I request admin to take over from here. Okay, so we have some questions as well. Okay, so someone has asked me how we can protect passwords. So, as far as I can see, protecting passwords, the first thing I'd say that you should probably avoid storing your passwords on your system. That is the first basic. Sometimes even your browser will ask you to store passwords. Like, do you want to save the password for the future? That is a very bad idea, trust me. You do not want your browser storing any passwords for that matter. And the best way to store a password is to write it down in an exercise book. Or if you actually wish to store the password in a medium, in a secure medium, I would recommend removable drives like external storage drives, or maybe flash drives which do not have much use. All right, so storing them on your phone is also not a very good idea, but then again, it's better than the system. And apart from storing passwords, you can also use an encrypted container to store passwords. But the best thing is always the hard copy, because there are a lot of good people out there doing bad things. So they'll be able to take passwords from any electronic medium, but they can't take your exercise book or your notepad, right? So that's not so easy. Okay, and another question says, how can we be safe on the internet? All right, like I said before you log into a website, let me give another short demonstration on how you can actually be safe on the internet. So let me share my screen for that. Here's the answer. Okay, so if I go to Google, I would want you to see something if it's visible. All right, so we can see that now. We have a couple of websites like HTTP and an IP address. If I can, I'll try to highlight that for you. Yeah, can you see that there is an HTTP and an IP address? Well, those are the kind of websites you really need to avoid. Okay, HTTP. Why will someone be using an HTTP website today? Everything is HTTPS, as I have demonstrated before. So this is something we need to avoid, and that's not the beginning or the end of it. The beginning is that you should be aware and also know that HTTPS isn't the end story. If it is an HTTPS website, we can even get into that website and script something. Maybe you can try. There are tens and thousands of vulnerabilities being stored every day. So obviously, you would want to take a look at the padlock before connecting to any website. Okay, and you do not want to go to any place or any website. Also, using certain antivirus programs blocks you from moving into a harmful website. So that's about it, more or less. And what else is there? How do I know about the apps I download on Play Store or App Store? Right. So when you download an app, obviously you will see the permissions that the app is asking. Suppose there is an example. I want to download a flashlight app. So if I want to download a flashlight app, why would the flashlight want to know my contacts, my geolocation, my battery level is fine. I understand that. But why my location, my contacts, my data? Why would an app want these things? So it's always important to check the permissions the app is asking for. That's pretty important. And apart from that, it's very important to see the source of your app. Is it legit? For example, I want to download an app from Play Store, right? So once again, I'll have to drop into a practical aspect, sharing my screen again. All right. So suppose I want to go to Play Store. So under these things, I would like some apps, maybe. Right. So in each app, suppose Subway Surfers. There's more to read. Apart from comments, there's what's new. There's a version. There's a website. So I would want to visit this website and check. I'd like to check out. I'd like to see. I want more information on the website. Right. See, this is our website. Before I download the app, I would like to see everything about the app. Who has made the app? What do they do? Are they a legitimate company? These questions, when you answer these questions or find a way to answer these questions, then you will know that the app can be downloaded or is it trustworthy. That's about that. What else? All right. Somebody is asking about error 404 and the reason behind it we get post phenomenon of client server. I believe this question is for Devashi sir, even though I could answer it, but I believe sir is more equipped to answer that question. Sir, can you see the question, please? The
Yes,
404
error
error.
404.
Hmm.
404, it is like when we are not finding any resource that is not there. So say for example I am connecting to a website, but I have misspelled the address of the website, so that website is not available or the web server is down. So there I can get this type of error. So that is not being able to connect to that, the resource is not available, resource is not there. So that is the error 404 is displayed there. So I
All
hope
right.
that this
So
answer this question.
all right. So that's about it. I guess there are no more questions. So I guess we can wrap it up in that case. All right. So it's good to see you all, and it's been really nice to hear Devashish sir speak and have we've had a lot of fun in this session, a good conversation. So that's about it for from my side, and we'll have another session the next time. Till then, please be aware, stay safe. We have a lot of viruses moving about. And one more thing about the awareness: these days, if you observe the news, you will also hear that people are calling you for the third dose of COVID vaccine. This is a special from the ICSS side. Please be careful about someone calling you about the third dose of COVID vaccine. Make sure you know who that is. And no COVID, no person calling you for a COVID vaccine third booster dose is going to ask you for an OTP or your password. Please be careful about OTP bypass and do not share your OTP with anyone. With that and current affairs, I bid you farewell and have a great day to everyone. That's about it. Admin, you can take over. Thank you so much.